See here terminal velocity. See here it is the maximum velocity attained by the body falling freely through a viscous liquid. See here, suppose any liquid you have taken here and a body is falling through this. When body falls through this, weight acts downside and upward there are the two forces. One is the viscous force that is coming due to the relative motion between the layers, and another one is your upthrust. Here we can write here upthrust. So, there are two forces acting upward and downward one force is acting, that is W, that is equal to weight. We can write here m into g. Now, if upthrust plus viscous force is equal to mg, that is the weight. In this situation, net force on the body is 0 and body has no acceleration. So, this is the velocity. In this case, whatever is the velocity of the body, that is known as terminal velocity. So, now we can write here upthrust can be written here 4 upon 3 pi r cube. R is the radius of this body. So, upthrust is equal to 4 upon 3 pi r cube, that is volume into density of the liquid, that I have written rho L into g, that is upthrust force, plus 6 pi eta r v, that is the velocity with which the body is falling. This is the maximum velocity attained, maximum constant velocity, that is known as terminal velocity, is equal to m into g. So, m can be written here 4 upon 3 pi r cube sigma into g, sigma. Here sigma is the density of this ball. So, we can write here 4 upon 3 pi r cube sigma into g. Now, we can solve this. We have to get the formula for the velocity. So, 6 pi eta r v is equal to 4 upon 3 pi r cube. We can take common, g also is common, and here we will be getting sigma minus rho L. And now, this pi and this pi will get cancelled, this r and this r will get cancelled, here is r square now, and this 6 is here. So, we can get 2 here, that is a 3, and here is 2. So, we will be getting velocity is equal to 3 3s are 9 years, 2 upon 9 into, that is 2 upon 9 into r square g, here sigma minus rho L divided by, this is eta here. So, this is the formula for the terminal velocity. So, now see here in this, from this formula it is clear that terminal velocity depends on, that is v is directly proportional to r square, radius of the square of the ball, and here also v is inversely proportional to coefficient of viscosity. It also depends on these densities. Suppose you are writing, if here rho is less than rho L, it means the density of the body which is falling through the liquid is less than the density of the liquid, then the terminal velocity will become negative. It means the body which is coming downward, that will start rising up. So, you might have seen air bubble like in the cold drinks bottle, these bubbles rises up. So, this is about terminal velocity, and here also there is a one extra concept which I have used in this, that is here upthrust. So, now after this terminal velocity we have to do here the different types of the flow of liquids.